Okay, we'll go through the process here for parts C and D. What I'm doing right now is showing how the z-score of negative 0.52 is the 30th percentile, again, for a z-score in a normal distribution. So that means that negative 0.52 is at or above 30% of the rest of the distribution, again, under the normal distribution. For me, I had to use my calculator. There's a way to look it up in a chart. I did inverse normal. I found that for the distributions. The area under the curve was 0.3, and mean and standard deviation were 0 and 1, so that it was a normal distribution, standard normal distribution. All right, showing this diagram is enough work to explain where the negative 0.52 comes from. So it's important that you communicate your ideas. You can do it through explanation or partially a diagram, partially an explanation. I think it's more effective to draw this and show this as to why negative 0.52 is your critical value. All right, so now we're actually, we're typing this into the standardized test statistic formula because it's a z right now, negative 0.52. We don't know the x value. We know the mean for this problem is 42 from earlier. Standard deviation is 6.5. So that's why mu is the mean, sigma 6.5, and it's just going to carry out the mechanics. Just to be safe, it's probably best to explain percentile if they do ask this question. It's at or it's high, as high or higher than 30% of the distribution. Same process for 90th percentile. It's going to be 1.28 is the z-score that is equal to or better, right, than 90% of the rest of the distribution under a normal curve, standard normal curve. We're converting that standard normal curve value, 1.28, over to an x, where in this case 42 is the mean and 6.5 is going to be the standard deviation. So we'll let that run. And again, I'm going to I'm going to explain why that's the 90th percentile. You want to make sure that the person scoring knows that you know what you're doing on this. Okay, so we'll save that. We'll go over to this. All right. And last part of this second question is explain why a score of 60 is considered unusually high for this distribution. What I did was, in a case where it's a normal curve and they give us the mean and standard deviation, an outlier is what we're referencing here. Okay? An outlier is more than 2 standard deviations from the mean. Okay? Now 60 is far above the mean. We've got to find out if it's more than 2 standard deviations above the mean. So if you see this calculation right here, 2 standard deviations, right, above the mean, so you get the mean plus 2 times the standard deviation. So 42 plus 13 is 55. 60 is more than 2 standard deviations above the mean. So it is considered an outlier or an extremely high score relative to the rest of the data in this distribution.